Hello guys, hope you're doing well. Today we're gonna talk about derivatives of parametric functions. Normally when we study derivatives, the function is written in the form y is equal f of x. In that case, we directly find the derivative dy dx. But sometimes both x and y are written in terms of another variable, usually called t. This variable is called a parameter. In this situation, we say the equations are parametric equations. For example, suppose we have x is equal f of t and y is equal g of t. Here, both x and y depend on the parameter t. Now the question is, how can we find dy dx? To do this, we use the following formula. Dy dx is equal dy dt over dx dt. In words, we say the derivative of y with respect to x equals the derivative of y with respect to t divided by the derivative of x with respect to t. So the process is very simple. First find dy dt, second find dx dt, then divide them. Let's look at an example. Suppose x is equal t plus 2e to the t and y is equal t squared e to the t. So we're gonna find that dy dx. First dx dt. dx dt is equal, since this is a product of two functions, we use the product rule, means t plus 2 prime times e to the t plus t plus 2 times e to the t prime. Okay, so we have the derivative of t plus 2 with respect to t is 1 times e to the t plus t plus 2 times the derivative of e to the t with respect to t is e to the t. So we have t plus 3 e to the t. Now dy dt is equal, we use the product rule, means t squared prime times e to the t plus t squared times e to the t prime. So we have the derivative of t squared with respect to t is equal to t e to the t plus t squared times the derivative of e to the t with respect to t is equal e to the t. So we have 2t plus t squared times e to the t. So dy dx is equal dy dt over dx dt. So we have dy dt is equal 2t plus t squared times e to the t over dx dt is equal t plus 3 e to the t. So the e to the t terms cancel. So we have 2t plus t squared over t plus 3. That's it. It's very simple. Number 2, if x is equal 1 minus cosine of t and y is equal 1 plus 1 half sine of t, we're gonna find dy dx. So first dx dt is equal, the derivative of 1 minus cosine of t with respect to t is equal positive sine of t, and dy dt is equal, the derivative of y with respect to t is equal 1 half cosine of t. Okay, so we have dy dx is equal dy dt over dx dt. So we have dy dt is equal 1 half cosine of t over dx dt is equal sine of t. And finally answer, we have dy dx is equal 1/2 cotangent of t. Number 3, x is equal t cubed plus 3t plus 1 and y is equal t cubed minus 3t plus 1. We're gonna find dy dx. First, dx dt. The derivative of this expression with respect to t is equal 3t squared plus 3, and the derivative of y with respect to t is equal 3t squared minus 3. Okay, so dy dx is equal dy dt over dx dt. So we have dy dt is equal 3t squared minus 3 over dx dt is equal 3t squared plus 3. So finally answer, if we divide both top and bottom by 3, we have dy dx is equal t squared minus 1 over t squared plus 1. Look at this example carefully. If x is equal t squared minus 1 over the square root of t plus 1 and y is equal e to the t minus 3 over t plus 1, we're gonna find dx over dy at t is equal 3. Be careful, we're gonna find dx over dy. First, dx dt. We use the quotient rule. Means the derivative of the numerator means 2t times the square root of t plus 1 minus the derivative of the square root of t plus 1 is equal 1 over 2 times the square root of t plus 1 times the numerator means t squared minus 1 over the square root of t plus 1 squared means t plus 1. So if t is equal 3, we have 2 times 3 is equal 6 times 3 plus 1 is 4. So the square root of 4 is equal 2 minus 3 squared minus 1 is 8 over 2 times the square root of 4 means 4 over 3 plus 1 is 4. So we have 6 times 2 is equal 12 minus 8 over 4 is equal 2. So 12 minus 2 is equal 10 over 4 or 5 over 2. Now dy dt is equal the derivative of y with respect to t, e to the t minus 1 over t plus 1. As you know, the derivative of e to the u is equal u prime times e to the u. So we have t minus 3 over t plus 1 prime e to the t minus 3 over t plus 1. So we use the quotient rule. So we have the derivative of t minus 3 is equal 1 times t plus 1 minus the derivative of t plus 1 is 1 times t minus 3 over t plus 1 squared times e to the t minus 3 over t plus 1. So we have when t is equal 3, so we have dy dt is equal 3 plus 1 is equal 4 minus 3 minus 3 is equal 0 over 3 plus 1 is 4 squared is equal 16 e to the 0 because t is equal 3 and this fraction is 0. So we have 1 over 4, and as you know e to the 0 is equal 1. Okay, so the final answer we have. So our goal is dx dy. Okay, so we have dx dy is equal dx dt over dy dt. So we have dx dt is equal 5 over 2 over dy dt is equal 1 over 4. So we have 20 over 2 or 10.